Today's modern enterprise systems increasingly rely on large language models to handle complex, automated, high-throughput data processing tasks. The issue is that these models are statistical engines. They operate by calculating the probability of the next word or token, rather than adhering to fixed, rigid logic. Flexible format invites structural hallucinations. The AI might invent a new field, misspell a property, or drop a column entirely, crashing the pipeline. Yet automated systems have no room for these errors. They require data that arrives exactly as expected, every single time. We are feeding data from an engine built to guess directly into pipelines that require 100% integrity. The format itself allows for drift that shouldn't be possible. Elton Bonin designed the BEJSON ecosystem to address this. Instead of repeating key names, it decouples the structural metadata from the raw data. BEJSON enforces its burst rule, positional integrity. The AI outputs data arrays mapping directly to exact index offsets in a field's header. A single missing comma shatters this mapping, causing instant rejection. The second constraint is type adherence. The model can no longer drift into ambiguity regarding how a piece of information is formatted. If the schema expects an integer and the AI outputs a string, or wraps a Boolean in quotes, the system triggers a hard error. These rules transform a flexible data contract into a rigid physical boundary. By removing the model's ability to drift, we eliminate the almost valid outcome. The final constraint is introduced in the BEJSON 104DB multi-entity format. Every record must start with the record type parent discriminator. The AI has to declare exactly what type of entity it is writing before it provides a single value. To maintain the coordinate space, the AI must fill unassigned fields with exact null padding, keeping the data grid unbroken. If the model hallucinates a value or assigns the wrong parent, the grid turns red and blocks the insertion. This zero-tolerance validation is enforced at the runtime level across Python, JavaScript, TypeScript, and Bash. It acts as a hard filter for incoming AI data. The AI is now entirely contained within a deterministic cage. Structural hallucination is no longer a risk. It's a computational impossibility. When an AI successfully outputs a BEJSON dataset that passes the validator's gauntlet, the status of that data changes. It is no longer just a guess. Because the rules are so restrictive, passing validation becomes a binary state of structural validity. While the model could still provide incorrect facts, it has proven it can map its reasoning to a strict column index map without drifting into structural error. The result is data that is clean, grounded, and structurally perfect, fitting into enterprise pipelines without the risk of silent corruption. This is why BEJSON serves as more than just storage. It is a diagnostic filter for structural drift. If the validator passes, the AI has successfully navigated the most difficult part of the contract. By permanently trapping a probabilistic engine inside a rigid deterministic cage, we finally enable highly reliable, zero-overhead AI integration.